In this video, we're going to take a look at how the internet actually works. We're going to do that by looking at the OSI model, which was created to standardize how computers around the world talk to each other. So this is kind of an important module. You might want to watch it a couple times if it's kind of strange at first. And I'm going to put in the link for the video a link to the OSI model, a PDF of what we do on the next few slides, so that you can download it and maybe even print it out if you want, so that you can reference it. This is really important stuff, especially as you become a programmer. You're going to want to know how the internet works, and you're going to want to know how information moves from one computer to another so that it can be transmitted and received properly and that everything gets there. So that is done through the OSI model, or the Open Systems Interconnection model. And there's 7 layers to this layer cake of how things work. And we're going to unpack it slowly over the next few slides. And like I said, if these are hard to see at first, I will put a copy of the information so that you can download this directly. But the first layer is the physical layer. Now, the physical layer is named the physical layer because it's the physical stuff. In other words, you can touch everything on the physical layer. It's the network cards, the cables, the modems, the switches, the firewalls. If it's part of the internet and you can touch it, it's on the physical layer. Okay, it's operating at the physical layer. Now, the software in a device obviously may work at the higher levels, but the equipment itself that sends the electric signals, the fiber pulses of light. I mean, if you had equipment that could send smoke signals and read them, even the smoke would be the physical layer, okay? If you can touch it, it's on the physical layer. All right, the data link layer is where our MAC address comes in that uniquely identifies the device that I'm using to connect and talk to other computers. And it means that I can send ones and zeros somehow between the 2 different computers. Okay, so the data link layer means I can link data between my device and other devices. Okay, I can send and receive information. Now, the network layer, or layer 3, is where I now have an IP address, and there's these things called packets that have a payload. They have information that I need or that I want to send, and they have basically where's it from and who's it to. Okay, so I can send it from my IP address to your IP address. You can send it from your IP address to my IP address, and I can receive packets from you. And you can receive packets of information from me. And we can figure out the best way to get from me to you, even if it takes a couple other hops to get to you. So we've basically established a network of devices that can move information around. Okay? Layer 4 is where we begin to manage those packets. For example, I take a picture of a very cute puppy, and I want to send you that puppy GIF. Well, that puppy GIF, as we talk about this, you'll see is automatically dropped and chopped up into packets, and I need to get those packets to you. Well, let's say there's 1,000 packets that make up that GIF. Those packets all need to get to you. And when I shoot those packets at you, one of them might take the long way around the bus. It may go via Albuquerque when it should have gone straight to you. When you throw packets on the internet, they just kind of fly towards the next point between me and you. And sometimes they go different ways. And sometimes packets get dropped or lost. So packets, we need a way to manage to make sure you got all the packets. And that's called the transport control packet, a TCP. The TCP layer of the internet, the transport layer, makes sure that the packets get to you. So if you are missing packets 3, 15, and 82, the TCP layer is going to send back to my computer and say, hey, I need these 3 packets. And I'm going to say, oh, okay, and I'll resend those packets. So there's a little bit of latency in TCP. In other words, if all the packets don't make it, there's going to be a signal back to me, and then I'm going to resend packets. Okay? So the transport layer makes sure all the packets get there. Now, there's a different type of transport besides TCP called UDP. And that means I'm going to send so many packets at you, and it's real time. I want it fast. I don't want the latency of making sure every packet gets there. I need you to get this information quickly. The best example of where UDP is used is in live broadcasts of sporting events, things like that. And if you've ever seen in bad weather, sometimes when they're doing a live feed via satellites, you'll see little squares of the image, it'll get kind of cubism, like little cubes will be missing, and then it'll come back and it'll get a little worse. Those are UDP packets that got dropped, that happen to become visible because of the refresh rate. Okay, so in live broadcasts, sometimes we're going to use UDP, which basically takes all those packets, throws them on the internet, and hopes they get there. Okay, but normally what we're doing is we're using TCP. Now, when you talk about layer 2 and 3, you're talking about TCP/IP. That is known as the language of the internet, and we'll talk about that again. So the transport layer makes sure that the packets get where they're going. It manages that transfer of packets. Then we get up into what's called the session layer. Now, if you've ever used software to log into your bank, you know what I mean by a session layer. If you sit on a particular website long enough and it times out and locks you out or logs you out, your session was terminated for a time. If you try to log into something and it rejects it because your password's wrong, your session has been rejected. That session management starts, ends, and maintains those sessions, and it keeps sessions apart from each other. So if I know that this bad guy over here is watching my session, he's got his own session with the bank, and I start and I log into my session, the system is set up so that he can't just jump into my session, right? Sessions are managed, and they're managed for security purposes, okay? So that's what a session is. It's a controlled interaction between me as the client and the server that I'm communicating with, okay? That's the session layer. Then we've got the presentation layer. I like to call the presentation layer the file format layer, because the presentation layer can also be where encryption occurs or decryption occurs. So if I send you an encrypted file and you have to decrypt it before you can use it, that decryption occurs basically at the presentation layer. When I send things over SSL, the decryption from the SSL is going to occur typically at the presentation layer. Once I'm done with the presentation layer, I have a file. All of those packets have been reassembled into a file that I can now use. So that when I go into the application layer, which in the case I'm talking about with my puppy is my browser, all of a sudden I can see the puppies. Okay, I'm using an application or a program or an app, whatever you want to call it, okay, and I get to use the information that I was sent. Okay, so the way this works, well, first let me go over a couple things. Depending on who you talk to, this first group of 4 is often referred to as the network layer. Okay, now not this network layer, this is the network stack. This is, they like to further categorize things, if you will. So kind of the networks piece of the network stack, all of this is handled by the network, if you want to think of it that way. And the top half, or the top 3, is pretty much run by the operating system, okay? So your operating system is going to handle these 3 layers of connection, and the network itself is going to take care of these 4. That's one way that people kind of further group these layers of the OSI model. Now, there's another school of thought that calls these lower 3 the media layer, because the media layer will change between fiber and regular coax or microwave or any of the different ways that you can connect 2 computers to a network. So this is kind of the media, and when you do it that way, they look at the top 4 as being known as the host layer. So the host computer is going to handle that. Okay, they're both right. Okay, it's kind of it's making a differentiation without a difference. Okay, so it's all fine. But what I really want you to understand is a couple different things. These 2 layers are what you will commonly hear known as the language of the internet, the TCP/IP layers. Okay, because the network layer and the transport layer are your packets and the control of those packets from one computer to another that might be in Japan. Okay, so that is the language of the internet. Everything comes across TCP/IP. Okay, so let's talk about sending that puppy GIF. Okay, when I have a picture, let's say I'm looking at it in my browser, or I'm looking at it and I've got it in an email and I'm going to send it to you. Okay, basically the application, whatever application I'm using, my browser, my email application, is going to say, okay, I need to send that image. So that image is going to go to the presentation layer, which is then going to move it to the session layer if I need to be logged in. And then it's going to come down to the transport layer and get chopped up into little pieces, into little packets. And each packet is going to get a number. And those packets are going to then get broadcast on the network layer towards you or whoever the destination is. And they're going to be sent via those data links. And those data links are going to go from one to the next, to the next, to the next, to the next, across the physical layer of the internet. Okay? And when it gets to your computer is going to pick up those ones and zeros, understand that they're for you because your MAC address is correct. It's going to take those packets. It's going to make sure that it got them all. It's going to check the session if there is one. Then it's going to turn them into a GIF and hand it back to your browser or your email application where you can open it and see the cute puppy that I sent you. Okay? So it goes this way when you're sending, and it goes up when you're receiving. And this happens hundreds of times a second. I mean, it's just really fast. When you request a web page, this could happen several hundred times just for that one web page. Okay? It's amazing how quickly this occurs. And a packet can go, if I were to take this mouse and drop it, I could get a packet around the world before this hit the floor. Okay? It's just amazing at how well this works. So, that is how the internet works. Again, take a look at this video a couple times if you need to kind of go over it to make sure that you understand the packets and how they work and how things are broken down, sent across the physical layer, reconnected and recollected and reorganized and back up to the application layer every time that works. Okay? Thanks. I'll see you on the other side.